Hi Jonathan, this is my attempt at the system software daemon CA. For this CA I stuck as close as possible to the separations of concerns principle and the single responsibility principle. So basically I achieved that by splitting out a lot of the commonality in the program into header files composed of different functions, and each function only being responsible for a single task. So anyway, moving on, I call my daemon webmon. So we can start the daemon by invoking a shell script I created called run. So if we just type run.sh into the terminal, it will actually call my make command. So if I show you that now, run that here, you can see it just makes clean first to get rid of any old object files that are hung over from the previous compile, then makes them all afresh and runs the actual daemon itself, and then does a PS just to print out the process IDs of the daemon. So you can see down below here, the daemon itself is actually running with an ID of 414052. The previous one is just grep. I used the singleton pattern in the creation of the daemon, so there can only be a single daemon process running at any time. I achieved that through the use of lock files. So I just want to demonstrate that when I print out the process again, it will actually say there's two processes here, but that's not actually the case. The daemon's actually 4052, and this process with the ID of 4054 is actually the timer process the daemon forks off during its initialization to count down towards the backup time for the live site. So I can prove that this is a singleton by trying to run the daemon again, and we should still only have the same two process IDs, and indeed we do. We have 4052, which is the daemon, and 4054, which is the timer process the daemon spawns, which are the same as we looked at previously. So that kind of proves that the daemon itself is actually a singleton. So the next thing I'd like to be able to show is the ability for the user to pass commands to the daemon through a separate process to force the daemon to do certain actions. Now, the way the user does this is it just uses the name of the daemon followed by the command. And how this works is that if you look at the code at the very start of the daemon, the first thing it does is it checks if the daemon is running. So if the daemon is already running, we go into this if, which essentially spawns off a separate process to the daemon, and then allows the user to pass commands via IPC, specifically an MQ, to the daemon process from this spun off process. So to demonstrate this functionality, I'm going to pass the backup command to the daemon. So the backup command should back up all the files in the live directory into the backup directory. So if we just have a look at my backup directory now, we'll see that it's empty. If we look in the live site, we'll notice that we have two files, index.html and new.html. So if I go back to the daemon now, and if I use the daemon name, followed by the command I want to execute, which is backup, you'll notice the daemon, or well, not the daemon, the separate process spun off by the daemon has actually reported back to us that the command has been sent. And the separate process is able to do this because it's not itself a daemon, so it doesn't close its file descriptor standard out. So it provides a handy way for us to report back to the user that a command has been sent. So now I suppose we should go back and see if the backup actually occurred. So if we look at our backup directory, it should have the two files in it, which indeed it does, which proves the backup functionality worked. Next, I suppose we should demonstrate the transfer functionality. So the transfer functionality is quite similar to the backup functionality, except that it takes files that live in the dev site. So you can see there's a bunch of files here, and it transfers them over into the live site. So we only have index.html here and new.html. So let's demonstrate that transfer functionality now. So if I go back to my terminal, we can execute the transfer command. So we can see the separate process again reported back to the transfer command. So let's see if the files ended up in the right directory. So yeah, we're in the live site here, and those files were indeed transferred over to the live site. So we're just over the 5-minute mark here. So fine, the last thing I'd like to show you is that the daemon itself has been logging all the interactions with it since I began through the syslog functionality. So we can see here that it has actually logged every action that has gone on in this little demo. And we can see at the end it's received a termination signal received and performing cleanup, and cleanup is complete. So that's my demo. The timer functionality does work, but I'm not going to have time to show it here. I'll mention it in the report. So thanks for watching this video, Jonathan. All the best.